So now I'm going to just go over here to do my particular solution, and I go back to 1, 0, 0, 1, 0, 1, 0, 0, 0, 0, 1, 0. And I'm going to do the same sort of process. Create my system of equations. X1 equals 1, X2 equals 0, X3 equals 0. And my XP equals some vector X1, X2, X3. Now what I'm going to do is I have my basic variables, which are my X1, X2, and X3. I have my free variables, which are none. And here, when I do my free variables, instead of letting them be anything, I'm going to pick a number for them to be. And because we can pick them to be anything, we pick them to be 0. Okay? But we have none, so we don't pick any. And now, once we've set our free variables, we define XP, and XP, well, we have X1 equals 1, X2 equals 0, X3 equals 0. I get that XP equals 1, 0, 0. So our solution equals 1, 0, 0 plus A 0, 0, 0. It's our solution vector plus any linear combination of our vectors from our span, from our homogeneous portion. Now, this example, kind of boring, not really exciting. Let's now look at an example where we have a subspace that has a span. Okay, and we're going to look at the example 1, 1, 1, 1, 1, 1, 2, 3, 4, 1. Okay, and our system of equations this comes from is going to be x1 plus x2 plus x3 plus x4 equals 0, and x1 plus 2x2 plus 3x3 plus 4x4 equals 0. And now row 2 minus row 1 replaces row 2, gives 1, 1, 1, 1, 1, 0, 1, 2, 3, 0. And now row 1 minus row 2 places row 1 would be our next operation. We get 1, 0, minus 1, minus 2, 1, 0, 1, 2, 3, 0. And now from here, we have our solving for SH. For solving for SH, we go to the augmented version of our homogeneous solution. Same augmented matrix in echelon form, but we replace it with the 0 solution. And this gives us the system of equations 1 x1 minus x3 minus 2x4, x2 plus 2x3 plus 3x4. And my basic variables are x1 and x2, and my free variables are x3 and x4. And x is in my solution space to my homogeneous. So it's equal to the vector x1, x2, x3, x4. What's my first step? My first step is to let my free variables for my homogeneous portion let x3 equal s, which is an element of my field, and x4 equal t, which is an element of my field. Now, x equals x1, x2, s, t. I now use my equations to update my basic variables. So x1 minus s minus 2t equals 0 implies that x1 equals s plus 2t, and x2 equals 2 or plus 2s plus 3t equals 0, implies that x2 equals minus 2s minus 3t. So this tells me that x equals s plus 2t minus 2s minus 3t st. And remember, we're now going to expand this. So it's s minus 2s s0 plus 2t minus 3t 0 t. And now I'm going to factor out, giving me s 1 minus 2 1 0 plus t 2 minus 3 0 1. So this gives me that sh equals the span of the set containing 1 minus 2 1 0 and 2 minus 3 0 1. So that's my sh. But now I'm going to solve for my xp. We're going to notice it's extremely similar steps. Extremely similar. 1 0 minus 1 minus 2 0 1 2 3. But now I go back to my homogeneous portion, and this gives me the system of equations x1 minus x3 minus x4 equals 0, and x2 plus 2x3 plus 2x4, sorry, this is equal to 1, and this is equal to 0. Well, now our basic variables are still x1 and x2, and they will always be the same. And our free variables are x3 and x4, and they will always be the same. And my x particular equals x1, x2, x3, and x4. And now what we can do is we can let our free variables be anything, but we're going to pick something. And we're going to pick something that's really nice. 0. x4 equals 0. You could pick anything, but the nicest thing is 0. And then we update our vector. So xp equals x1, x2, 0, 0. And what's really nice is now when we read off our equations, our first one tells us that x1 equals 1. Our second one tells us x2 equals 0. And we directly get our xp vector straight from our equations. Super easy to read off if we let the free variables be 0, and we get our particular vector. So our solution is going to be the set 1 0 0 0 plus x, where xh, where xh is in the span of a set 1 minus 2 1 0 2 minus 3 0 1. And that's our solution. So now we've gone through a bunch of examples, all of which had a solution. The last thing we're going to look at is we're going to look at an example where we don't have a solution. And we're going to look at 1, 2, 3, 2, 4, 5. And this comes from x1 plus x2 equals plus 2x2 equals 3, 2x1 plus 4x2 equals 5. Here, we're going to take row 2, subtract 2 row 1, placing row 2. This gives us 1, 2, 3, 0, 0, minus 1. Well, now when we create our system of equations, we get x1 plus 2x2 equals 3, and 0x1 plus 0x2 equals minus 1. Well, now here, this equation, this implies that 0 equals minus 1, which is inconsistent. Thus, we have no particular solution, or therefore there is no general solution. So when we get that row of zeros equaling a 1 or a number, we get this. There's an inconsistency in our system of equations. We do not have a solution. Now, given we don't have a solution, what does that mean in terms of our original questions? We've now gone over how to solve all the different cases we could have. You have no solutions, you have an infinite number of solutions, you have one solution, but you've got your homogeneous, you've got your non-homogeneous. But remember, we've got to answer questions. So if we scroll way back up, when we first defined our questions, we had our questions, and then we had our, how do we answer those questions? So how do we represent it as a span? What we do is we create that system equation and look at the solutions vectors as a span. But how do we check if a vector is in the span? We take this linear combination and ask, is there at least one solution? And here we're asking, is it linearly dependent or not? Well, is there a non-trivial solution? If it only has a trivial solution, it's linearly independent. Otherwise, it's linearly dependent. And in your homework assignment, you're going to explore a few more situations. We have to be comfortable with all our situations. And that is where we're going to end it.